Welcome to Brain Vision.
A sealed metal container can withstand a pressure difference of 0.5 atmospheres. The container is initially filled with an ideal gas at 18 degrees Celsius and 1.0 atmosphere, 1.08 EM. To what temperature can you cool the container before it collapses? So we're going to start off from our ideal gas law, but we're going to write out two versions of it. So in one situation, we have P1 V1 is equal to, so pressure times volume is equal to number of moles 1 times the gas constant times temperature in situation 1. We're going to call that equation 1. So for equation 2, we have P2 V2 is equal to N2 RT2. And these are our two laws, and we're going to call that our equation 2. So simple gas law, written out twice for two different scenarios. Divide 1 by 2, so we get P1 over P2 dot V1 over V2 is equal to N1 over N2 dot T1 over T2. Pardon me. So in this circumstance, we have a sealed container. So that means that we can ignore the change of volume because it's assumed to stay the same. And because it's sealed, also the number of moles stays the same. So we have the P1 over P2 is equal to T1 over T2. So our unknown is our temperature, our second temperature. T2 is our unknown. So making that the subject of the formula, we have that, or subject of the equation, T2 is equal to T1 dot P2 over P1. P1 is a 1 atmosphere, and a pressure difference of 0.5 means that P2 has to be 0.5. So T2 is equal to 0.5 times T1, and T1 is equal to 18 plus 273 Kelvin. So we have 291 Kelvin dot. So, or multiplied by 291, which gives us T2 is equal to 145.5 Kelvin. So T1 is equal to 145.5 Kelvin. And that is equal to minus 127.5 degrees Celsius. And I believe there's a mistake in the answers in the textbook whereby the answer is not given by this, but the answer in the textbook is given by minus 126.4 degrees Celsius. I don't know where they get that from. This is clearly the correct answer, unless somebody can spot a mistake in my working. I believe what they might have done is calculated out the full thing and maybe made a rounding error somewhere by carrying through on too many different equations. It's much simpler to do the algebra beforehand and just substitute in all the knowns once you've simplified the algebra, is what I would say. And that avoids making silly mistakes like rounding errors. Anyway, the answer is T1 equals minus 127.5.